All right, ladies and gentlemen, I wish I had some dramatic music to intro this video with. This is the last video for your summative test on Chapter 5 on linear relations. We just have 9 questions, just like the previous one. This will be the format of your test. This is the first 3 are all the same thing. I'm giving you one thing, you give me 2. I give you another thing, you give me 2. I give you one thing, you give me 2. That's the format of all of it. If I give you an equation, you give me the table of values graph. If I give you a graph, you give me the others. And the first row is like a level 1, fairly easy. The second row is a little bit harder. And then the third row is a little bit more complicated. So we have progressively harder questions as we go down. Let's go through this together one at a time, and hopefully this will all resonate with you all. First equation says the value of 2x plus 1 equals y. Okay, this is a linear equation showing the relationship of an x-axis and a y-axis, or in terms of graphing, the x-axis and the y-axis. When we have an equation where there is both the x and the y, there is a relationship between values of points that can be graphed onto that Cartesian plane that will always form, unless we use exponents, a line. Once you get into grade 10, you'll learn that when exponents are factored in there, they create all these fancy little things called parabolas and stuff like that, which you will learn in grade 10. But for right now, all we're worried about is if you're given the equation, can you plot those points? So the table of values is so simple, it's not even funny. All you have to do is make a table of values showing your x and your y. Since we have just 3 points, we'll make a perfect line. 2 points will make a line, obviously, but 3 will prove that it is a line because they will connect to each other in a straight line. We randomly choose any 3 points, which the best of the random numbers are your 1, 2, 3. And once you have that, all you have to do is take your equation and substitute your values of 1, 2, and 3 into those equations. Once you do that, you can simplify using BEDMAS, meaning 3 will be your y. So when x is 1, y would be 3 when you simplify that out. If I do that for the second one and substitute for x is 2, y will be 5. And at this point, we probably can guess the next one based on just our experiences with patterns. We know it's 7, but we can prove it by simplifying this over here to figure out the y value. When x is 3, y will be 7. Now we have to graph it. And our x-axis here, our range of numbers go from 1 to 3. So I'll just put 3 equally spaced lines there. And on my y-axis, the range of numbers goes up to 7. Now don't start at 3. What you want to do is start at 1. So 1, 2, 3, 4, 5, 6, 7. If you do start at 3, and I guess I should show you this anyway because it's something that might appear in your test, you're going to do one of these things called a break. And that break means I am ignoring the first few numbers because I don't want to graph them. And it basically means you compress the line like a spring all the way down and start it at 3. So you could do that and go 3, 5, 7. You just eliminated, you push down the y-axis so that you're starting at 3 instead. That is something you might see on your provincial exam, but it's not something you're going to see online. We're just going to go 1, 2, 3, 4, 5, 6. Hang on. Make it better. 1, 2, 3, 4, 5, 6, 7. There we go. Equally spaced. 1, 3. You start with your x, you start with your y. 1, 3 is there. So it's 1 and 3. In fact, you should label your axes. 1, 2, and 3. Then you're going to go 2, 5, which is there, and you're going to go 3, 7, which is there. Connect the dots. You have your line. What's that line called? That shows the relationship between x and y with the equation 2x plus 1. Now, just to talk about the 2 words of interpolate, because we didn't really talk about it, should be on your cheat sheet if you're making it. To interpolate is to look in between known points. So the 3 points I do know are those 3 big black dots there. If I was to surmise, not substitute, not do anything else, but if I said if x is 1.5, if x is 1.5, without inserting it into the equation and simplifying it through order of operations, I can interpolate going in between points by doing this. Take my line here. Take my line here. Oh, sorry, it should be right here. It should be right there. That should be right there, roughly. And I could guess, approximately, since my graph is improper, that the value of x based on that interpolation would be right here. That's where the point would be on my graph if I interpolated 1.5x. And I could use that information to figure out that the y would be 4, correct? That's called interpolation. And I could actually substitute just to make sure. Does that work out to be 4 for the y? It does, right? The other word that you learned that we didn't use, but I'm going to talk about it, is to extrapolate, which is the same thing as interpolate. The only difference is instead of going between 2 points that I know, I'm going beyond points that I know, right? So I can actually guess what this is based on its relative position to x and y on that, okay? We're not going to do that. I just want you to be aware of it. Does that make sense to everybody? I might ask you those in vocabulary. I just might ask you those 2 words just because they are required learning for the chapter, but that's all it means. Any questions on that one? Our second question gives us a graph, and we need a table of values and an equation. Piece of cake. Table of values, x and y. This time we're not randomly choosing because we have them already assigned. If I grab my green marker and figure out what point this is, it's 215, and I actually gave it to you just because my graphing wasn't very good. So that means 2 is your x value, is always the first one, and 15 is your y value, always the second part of your ordered pair. The next one is 3 and 20, and the other one after that is 4 and 25. Somebody asked me very smartly, what would happen if you started with this point instead? No problem. It would be 425, it would be 320, and it would be 215. Either table of values is going to garner the same equation. I'm just going to show you with both of them just to show you. In order to get the equation, which is our next step, you need to leave kind of a template for your x and your y, leaving a space for a coefficient and a constant. To determine the coefficient, what you need to do is you look for, the formula is very simple. The difference in the y column, which looks like diffy, divided by the difference of the x column will garner your coefficient. Since the difference here is going up by 5 each time, and the difference here is going up by 1 each time, for that particular column, it's going to be the difference of y divided by the difference of x, which equals positive 5. If I do the same thing with the other column, which I just have different values, here it's going down by 5, and here it's going down by 1. But as you can see, if I substitute that into my formula, it's still going to give me the same coefficient no matter which way I do it, right? Does that make sense to everybody? So it really didn't matter which way I plotted it. Once I know my coefficient, I'm going to insert it into my blank template, just like that. In order to determine if there is a constant needed, take any ordered pair, substitute it in. My x is 2, my y is 15, just like that. When I simplify that, it becomes 10 and 15. Since they are not equal, the only way I can get that to be equal is to have a constant, and that constant is plus 5. And therefore, the equation that matches that line is 5x plus 5 equals y. Now, don't just on your test leave it like that and say that's got to be it. Okay? What I would also ask on your test is you verify it. So that's the one you used to start. Use any other one. It doesn't matter. I'm going to use this one here. Take that equation, and to prove to me that you know it's true, substitute it one more time. So x is 4, y is 25. If these two work out, then when x is 4 and y is 25, then it works. And it does, because 25 is equal to 25, and therefore it is the solution. Okay? Don't forget to check on each of those particular ones. All right, we're going to go quickly on these ones because now we have the information, or actually I'll do one more like this. So equation and graph. Your equation, difference of y is going up by 4. Difference in x going up by 1. Your coefficient is 4. Substitute. 0, 8. Constant needed, plus 8. That's your equation. Once you have that, you can then figure out the missing values here and here. It says, if x is 100, what will y be? So, taking your equation, if you substitute x for 100, and I'm not going to write it out, but you can see how it's going to be 4 times 100 is 400, plus 8 means y is going to be 408, right? 408 like that. And that's how you solve that one. That's on your test. The other one is when you're given a y value and asked to determine the x value, really what we're asking is to extrapolate this. We're going beyond. I should have made my graph first, but I didn't. Take your equation, substitute y for 792, and substitute it using your awesome algebra skills. Subtract 8 from both sides to isolate the 784. Divide both sides by 4. Brain's not braining. Can I do that in my head? I could, but my brain's not working right now. 196. So over here, you're going to fill in the chart with 196. When x is 196, y would be 792. That is basically using the equation to extrapolate that information rather than looking on the actual graph. And finally, to graph it, since I'm looking at these 3 points only, and all I'm dealing with is positive x values and positive y values, if you go back to grade 7, oh, hold on, I need 3, right? I'm going to 1, 2, 3, and then I need up from 8 to 16. I'm going to use this little squiggly line there. I'm going to compress this down, right? I'm going to ignore the 1, 2, 3, 4, 5, 6, 7. I'm going to start at 8, and as long as my spacing is okay, that's 8. I'm going to go up by 4 each time. 12, 16. So 8, 12, and 16. If you do it that way, though, you need to have this little compressor here. Otherwise, you would need to show, I guess you only need to show 4, right? Because really, technically, what I'm omitting is the ones I don't need, which is your 9, 10, and 11, your 13, 14, and 15. If you want to put them in, you can. But that's how you would do it. And you get your 1, 2, 3. You got 0, 8, which is right there, 0, 8. You got 112, which is right there. And you got 2, 16, which is roughly there. There's your line. Question number 4 gives you an equation, table of values, just like we said before, 1, 2, 3, 1, 2, 3, 1 is 1. 2 is 5. 3 is 9. Now, obviously, you're going to show your work a little bit differently for that, but that's how I did it because we want to save some time. Once you have that, to graph it, piece of cake, same as we just did in the last question, 1, 2, 3. Here I start at 1, go up to 9, so I'm going to use 9 lines, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 1, 2, 5, 3, 9. Line. Question number 5, table of values and equation. X and Y. That's a 5 and a 4. That's a 10 and an 8. That's a 15 and a 12. That's a point for your table of values. Your equation, it goes up 4. Your equation, it goes up 5. The difference of 4 divided by 5 as a decimal is 0.8. Dig it! Once you have that, your coefficient is 0.8, which is a familiar coefficient to a grade 9 student because this is the year we use decimal coefficients. Once you have that, substitute any ordered pair. Now I got to multiply. Oh, I'll just choose these. Why not? Let's just use this. Okay. So I substitute 5 for my x, 4 for my y. Guess what? What's this tell us about our equation? It does not require a constant. So therefore, the equation for this one is simply 0.8x equals y. Now you could have kept it as a fraction, and therefore 4/5 x equals y is also acceptable. Or if you're a super genius and realize this is multiplication, meaning 4/5 multiplied by x, or x over 1, you could have also written the equation next level stuff. But all 3 of these equations are exactly the same thing, and they all match the line. Yes, that was for you. I just did a snap in virtual airspace, and nobody can see it, just me. Equation. What's this one go down by? 4. What's this one go up by? 2. Negative 4 divided by a positive 2 will give you a negative 2 coefficient. Substitute 4 and 4. That seems easy. Chloe, constant needed is what? What do you add to negative 8 to get a positive 4? I think it's 12. I might be wrong. Therefore, that is your equation. Seeing if you're awake. When you graph it, however, my x values are going to require both positive and negative. So I'm going to need to have that type of drawing because I need to do a positive and a negative x value. My y, oh sorry, that's a lie. I did that the wrong way. Oopsie daisy. My y column needs positive and negative. My x column only needs positive. So I need to go from 4, 6, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And my y value needs to go from a positive 4, 1, 2, 3, 4, to a negative 4. So that is the section I need to use for my y-axis. And this is my x-axis. All my x's live in, anybody? Carter? That's right, Texas. All my x's live in Texas. Great country music song. It's a great country music song. Someday you can listen to it. So that is 4, 4. That is 1, 2, 3, 4, 5, 6, 0. And, oh, what did I do wrong? That's not 6, 0. 1, 2, 3, 4, 5, 6. Yes, it is. What? 4, 4. Yes, it is. And then this one will be right down here. That's right. There's your line. Okay. Finally, into your equation, if x is 100, substitute it. Or is that supposed to be 12? Okay, so once you have that, you get negative 188 for your y value. So your y value is negative 188. Oh, 188. And then when y is 64, just take your equation, substitute 64 for your y, and then use your algebra sense to solve. Minus 12 to both sides. 52, divide both sides by negative 2, and x will equal a negative 26, which goes there. Question 6, trying to go as quickly as possible. Table of values, boom, 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 boom. Mr. Mack, make your wise look more wise. You are not wise, it is wise. When you substitute 1, yes, thank you, dad joke number 4, and it's all, not even 9 o'clock yet, 9:30 yet. Substitute this. What will that work out to be for the y value? If you can do it in your head, great. If you can't, use your calculator for the love of God. It is positive 0.5. When you substitute 2 in, you get, oh, sorry, I forgot to put that in there. You get 0.25. And you could probably guess what 3 will be, correct? Based on the pattern, we know it's 0, but we'll just double check. And it is because a negative and a positive of the same value will make 0. Once we have that table of values, you're going to graph it. Your x-axis only needs to be in the positives. Your y-axis only needs to be in the positives. So 1, 2, 3. We got to go from 0 to 0.5. I'm going to go 0. You know what I'm going to do? I'm going to go crazy. I'm going to go crazy. 0, 0.25, 0.5, 0.75, and 1. I'm going to make my units all up by increments of 0.25. I'm going to put my 1 here, my 2 here, and my 3 here. 1, 0.5 will be right here. 2, 0.25 will be right there. And 3 and 0, the worst graph of all time. Worst line ever. See if I can change that. See if I can move it over here. There. Oh, look at that. Perfect. There's your line. Okay, real quick, last ones. No numbers given. If you do have this question on a test, it's probably a good idea to put your numbers in. Just like that. Hey, the 1 does double duty there. Look at that. Isn't that great? Your points are negative 4 and negative 1. This is 0, 0. Do you guys remember what 0, 0 is called from grade 7? That's right. It's called the origin. And then you have 4 and 1. So in your table of values, it does not matter which way you go. I'm going to go this way here. So negative 4, negative 1. 0, 0, 4, and 1. Difference of your y is going up 1. Difference in your x is going up 4. 1 divided by 4 is 0.25. So once you know your coefficient of 0.25, insert it in, just like suchly. Okay? Then you take any ordered pair. Obviously, if I had to choose one, that seems like the easiest one to do. Correct? Inserting a 0 for my x and a 0 for my y looks like that. And therefore, just like the last question, this particular table of values and this particular graph has an equation that does not require a coefficient, and therefore your answer is that, or if you want to make it as a fraction, that, or if you want to be sophisticated, that. They're all the same equation, but that is the equation that matches that line. And our very last question gives us a table of values. I'll come back to it right at the end. Asks us to make an equation and a graph. So obviously, if we're going to make this equation, we need to know what our coefficient is. It's going up by 4. It's going up by 6. A general mistake people make here is when they see this, because they're both negative numbers, they think it's going down by 6. Make sure you know that from going from -10 to a -4 is going up by 6, not down. So the difference in y is going up by 4. The difference of x is going up by 6. Therefore, your coefficient as a lowest term fraction is 2/3 or 0.6 repeating. Your choice to which one you use. Generally speaking, in algebra, it is much better to use a fraction than a repeating decimal. So that would be the choice that you should make. But because it really doesn't matter, we're going to use repeating decimals. So our coefficient is 0.6x. Actually, let's do both, just to show you the difference. Okay. Once we have that, choose any ordered pair. That one seems easy. I'll use that. If you look at both of these, right, if you're using 0.6 repeating as a coefficient, or if you're using 2/3 as a coefficient, I think most of us would see which one would be easier to work with. The fraction is actually, in this case, an easier coefficient to work with. Because when I go to my calculator and say, dude, I don't know what this is, 0.6 repeating, you really have to do this in your calculator, don't you? And then you say times 2 equals 1.3. Now you can disregard that 2 because we didn't get to put it all in. We know that that answer is going to be 1.3 repeating x, correct? When you multiply the coefficient by the first number we chose here, 2, our 9 has to go over here, correct? Is that how it works? If we do it this way, we can see that my answer is going to be 4/3. Sorry, not x. Did I say x? Sorry. That's the mistake I made. Okay. And over here, we're going to have 9. Okay. So the question is, what do you add to 1.3 repeating to get 9? Well, obviously, if I add 7, that is going to give me 8.3 repeating, in which case, what more do I need to get to 9? If I'm at 8.3 repeating, anybody? I need to add that, right? And those two will combine to get 9, and therefore, that's your equation, right? If you used decimals. If you do that same thing and say 4/3 is 1 1/3, what do you add to 1 1/3 to get 9? You add 7 2/3. All right, 7 2/3. Now, obviously, if I'm looking at those equations, they're both fairly complicated-looking equations, but if I had to choose between this one or this one, I'd much rather use fractional coefficients than I would decimal coefficients. And then your graph, finally, oh shoot, what was the equation again? I just erased it. What was it? As a fraction? It doesn't matter. It doesn't matter. We just have to graph it. So on my x-axis, meaning my vertical axis here, I have negatives and I have positives, which is going to require negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 on the negatives, 2 on the positives. That's as far as I need to go. I'll just keep it going up here just to make it look, what's that word called? What's the word called when you have things equal on both sides? No, where you have it like symmetrical. And on my y-axis, I only have positive, so I don't need that bottom line. But I do need 9 spaces. So technically, you don't need this part. That's all you need for your graph. So negative 10, negative 9, negative 8. There's our space. Negative 10 on the x, 1 on the y is right here. Black dot. Negative 4 on the x, 5 on the y is right there, roughly. And 2 on the x and 9 on the y is roughly there. Oh, look at that. That actually wasn't so bad for a line. And there is the line that matches the graph. Now, I could talk about this part here. That's the y-intercept. That is if x is 0. And we could actually substitute that in. I think it actually works. Okay, what's the equation again as a fraction? Tell me the equation again as a fraction. 2/3 x plus 7 2/3 equals y, correct? Okay. So does everyone agree that that line works? And does everyone agree that if I put a red dot right here, that's where the line crosses the y-axis, correct? Can anyone tell me what number that roughly is if you're looking at it on the, it is 7 2/3. So even though my graph wasn't so good, when x is 0, which I'll substitute in, when x is 0, y will be 7 2/3, which it is. And my line is actually not bad for a guy who just kind of eyeballed a graph. Therefore, that's a pretty darn good line.